So I was presented with this brilliant formula to compute the area of a trapezoid. Brilliant! But how does it make sense? It looks like base 1 times height. So base 1 times height. Well, that would give the area of a rectangle. Plus base 2 times height. So this base 2 times height would be the area of sort of a smaller rectangle inside the trapezoid. And we add those two areas together and then divide by 2. Cut the sum of the two areas in half. How could that be? So I tried to visualize it here. So the base 2 times height. I wanted to start there. So base 2 times height would give the area of this orange rectangle sort of in the center of the trapezoid. And then base 1 times height would be, ignore that for a minute. Base 1 times height would be the area of the rectangle here in green. And actually, now I remember what I wanted to do is put the orange one embedded in there. So base 1 times height is the green area, all of it in there. Base 2 times height is the orange area. And I did want to separate those out so that we could see what the sum would be. So really what we're saying is base 1 times height plus base 2 times height would give us the area of this green rectangle plus the orange rectangle together, which is clearly more than the area of the trapezoid. And for some reason, the area of the trapezoid is half the area of the green plus the orange. Or you could say the area of the green plus the orange is double the area of the trapezoid. I made it kind of more obvious here in blue. So the entire area of the green plus orange, this rectangle up here, is twice the area of the blue trapezoid now. Or the blue trapezoid is half the area of the entire rectangle green plus orange. How could that be? Well, if the area of the blue trapezoid is indeed half of the area of the entire rectangle, it would make sense that within this diagram are two of those blue trapezoids, right? Because if the blue trapezoid is half the area, then two blue trapezoids would be the same as the whole area. So somehow inside this big rectangle are two of those blue trapezoids. Let's see if we can find them. Now, just to kind of make it more clear, I took the blue trapezoid out just to make some white space. And now I'm going to show you that with the remaining this and this, we can make another trapezoid. Actually, I did it here, I think. Let's see. All right, so with the remaining, we can make another one of those trapezoids. If we pull that base 2 times height out, and then I'm going to take this green triangle and actually flip it around, and then put it here. And then take this green and put it over here. And look, we created another one of those trapezoids. So yeah, within that whole sum are actually two of those trapezoids. Therefore, the area of one of the trapezoids would be half of the area of the rectangle, because within the rectangle are two of those trapezoids. Now, there's another way one could look at it to see it. I actually kind of prefer that nice visual proof. You can see why we need to take the sum and divide by 2, since we just want half of that total area. But we can also see it more algebraically. Let me show you here. Get my drawing tool out. So your formula was base 1 times height plus base 2 times height divided by 2 is the area of a trapezoid. Well, if you look at the numerator here, this product and this product have a common factor of h. So there's a a thing we can do, we sometimes refer to it as, or we use the phrase factor out the h. Since the h's are factors, we can do this thing where we factor out the h and say that b1h plus b2h is equivalent to saying h times base 1 plus base 2. And what we're really doing is reversing the distributive property. If you distribute h back through, if you multiply h through that sum by the distributive property, h times b1 gives you this product, and h times b2 gives you this product. And so these two lines are equivalent ways to express the same thing. Now, in terms of traditional formulas, I think you had it on your work here somewhere too. Where is it? Here it is. How did you write it? Yeah, you wrote the formula this way. See if you can see it. So we've got now this sum, base 1 plus base 2, times h, but then the h is half, so you could think of it as 1/2 times h. So this is just a rewriting, reconfiguring of the exact same stuff we have up here. And so, yeah, by some algebraic maneuvers, we can also show that these formulas are equivalent. But I kind of like this one better to see it visually, that there's two of those blue trapezoids in there. And so the blue trapezoid area is just half of the sum of the areas of the two rectangles. Hope that helps.